from home, okay, as everybody, almost everybody now, especially in Spain, we are obliged to. Okay, so sorry for all this disorder behind me. Okay, so first of all, maybe for those that do not know me, maybe I can introduce myself a little bit. Okay, so I'm Marcos Martínez from MaxLinear. I work in the Comms department, which is basically working on the system architecture of our chips. And I'm in charge mainly of standardization processes on wide technologies. Okay, so basically in my case, I'm more focused on home connectivity, and that involves mainly HN, a little bit of MOCA, but also other technologies. Okay. So I participate in the development of G.hn technology, attending the standardization committees involved with that technology in ITU and Home Forum, and I'm also a member of Broadband Forum, where I work in several projects for home connectivity, and that's why I'm involved in all this Wi-Fi mesh stuff, okay, because that's part of it's a big part of the strategy of MaxLinear. So I've been participating in Wi-Fi Alliance for some time, in PF, ITU. Wow. So as you understand, from MaxLinear perspective, I mean, we have been collaborating with prplMesh, even if we are not members. We have been collaborating in the development of the prplMesh solution through Mario Math, that is also on the call. But of course, our main interests are two. First, because we really think that prplMesh needs to succeed. I think that is for the market to have an open source solution, because there are plenty of proprietary solutions out there, and we think that the future of this technology is by going through open source. Okay. And the second interest is because since this technology was created by Wi-Fi Alliance, we think that there is quite a lot of focus on Wi-Fi, which is very good, okay, because everybody agrees here that all the front haul links have to be Wi-Fi, okay, because that's what the user is expecting. But we feel that there is some work to be done, and some optimizations can be done on the backhauling, and that's where G.hn technology plays a role. So our second objective in prplMesh is indeed to include G.hn and MOCA, by the way, because that's another technology that is very useful for backhauling. How we can integrate these wide backhauling technologies in the overall solution in order to create a very general solution for the home network. So that's what my contribution is all about, because obviously it's not so straightforward, and there are some things that need to be done. So now I will share my screen. Just a second. Okay. Let me just. Can you see my screen?
Yes, we can.
Yes, can hear you. Okay, so actually Mario asked me to prepare this presentation, so I got some slides here and from here and there. Many of them were internal slides that we used to try to set up our plans. So I hope the whole context gives you, well, the whole slide sets have some coherence. Okay. So, I mean, I will not teach you anything new about the Wi-Fi mesh concept, but at least I think it is good to share what are our views on what the Wi-Fi mesh concept is, and what are, from our expertise as a connectivity or a service silicon vendor that provides connectivity solutions. We have been talking with several service providers and integrators, and we think that we identified quite well what are the challenges and why Wi-Fi mesh is needed. Okay. Basically, well, everybody knows that the main problem is coverage. Okay, it's not really the throughput. Actually, the throughput is something that is very good for speed test and all that, but At the end, if you provide around 100 megabits per second, that's good figure. Okay, the more is better for sure, but the minimum, the bare minimum would be around 100 megabits per second. But what is a must, and that's something that is the main issue for final users, is the coverage issue. Okay? Because you cannot, you really cannot afford to have a connectivity system that have some blind spots. And actually, well, that's my case right now. Here where I am in my house, this room is not covered by Wi-Fi. Okay, the Wi-Fi is simply not arriving here. Okay, so I need to use other solutions. So basically, EASYMESH is about coverage in our understanding. Okay, so you collect all the data around the access points, and you set up you try to set up the network in order to minimize the blind spots in the house. Okay, that's exactly what everybody's. And for that, as you know, you have several access points. And what is very important to understand is that not all these links are the same. Actually, you have, even if they are dynamically changing, okay, but at the end, EASYMESH is building a tree, and a logical tree, actually, not a physical one. And this logical tree is composed of front haul links, which normally or by the standard are always Wi-Fi, okay? And backhaul links, which are the interconnection between agents that are that may be Wi-Fi or maybe Ethernet or any wired technology. Regarding the front haul, it's also interesting to mention that even if the Wi-Fi alliance defined in EASYMESH that the front haul is always Wi-Fi, it's not always the case, okay? Because you have many cases, like in my own case. I mean, you have things that are connected through Ethernet because it provides better latency. So for PS4, for instance, you really don't want to connect it to Wi-Fi if you have the possibility to connect through Ethernet. Okay, so these kind of cases were not really well considered in Wi-Fi alliance, and something will need to be done in the future. And another important thing that differentiates EASYMESH from other services that were similar but that were older, okay, is the fact that in EASYMESH you don't need an agent in the final user. So nobody wants to install an app in your mobile phone or in your tablet. And in the past, that was the case always in this kind of systems. EASYMESH does not need that. Okay? So that's, I think, one of the powerful features of EASYMESH. So please interrupt me if you have any questions. But I think this is common sense, and that's widely known by people. So what's the role of the wired backhaul in EASYMESH? And as I say, sometimes it has been minimized a little bit in Wi-Fi alliance, or at least oversimplified. So basically, you have three types of wired backhauls for a system like EASYMESH. You have Ethernet, obviously. Okay, so I will not speak about it. I mean, it's really quite straightforward. But it's quite rare to see, especially in some geographies, to see the house that is wired with Ethernet. It may happen. Okay? It happens in new installations or some freakies that want to have a complete wired backbone. It's not very usual. Okay? So the other two types are using MOCA, which is basically coaxial. That's something that is quite common in the US, especially, and in some countries in Asia, where normally you have a coaxial installation up to each room. So it's an ideal backbone for access points because, well, you already have a network set up. It's a network that is able to deliver 1 gigabit per second. So why not to use it for access points? So if it is there, okay. It's very good. As I say, it's quite typical in the US and some Asian installation, and in some European countries, not so many. And the third type is PowerLine. Okay, PowerLine is a well-known technology. There are several flavors. I will only talk about G.hn, but there are, of course, it is also Humbler, okay, which is something that is also widely used. Powerline, well, it has a big benefit, which is very easy to install, and it provides good throughput at a relatively low cost. Okay, so I would say that even if the throughputs that you can achieve are not the same as if you are using coaxial lines, it is something that for low-end users and mid-end users are quite is a quite practical solution. So how is this handled today in the EASYMESH standard? Actually, all these technologies are gathered together. Ethernet, MOCA, chain, home plug, are gathered together in the concept of logical Ethernet. Okay, so whenever EASYMESH talks about Ethernet, actually it means logical Ethernet. It can be a physical Ethernet, a normal Ethernet cable, or it can be something that is transporting Ethernet above another technology. Okay. So the answer is yes, they are handled in EASYMESH. Okay, but it is true that the treatment of these technologies is not optimal today. Okay, they do I would say in a way the bare minimum. So as I say, using this wired technology has several benefits. Okay, the first thing is that these technologies, obviously with coax, is quite normal, but also with Powerline, you can get larger coverages. Okay, this is especially true if you are using Wi-Fi technologies that are more advanced, where you have more throughput, but it is also true that you have less coverage. In Powerline, in general, you may have the possibility to have longer hops, okay, which reduces the number of devices that you need to have in your home. Okay. Another big advantage, and that's particularly important for the backhauling, is that these wired technologies provide a more stable and predictable throughput and latency. This is especially important in the case of latency. Okay. Well, I'm putting here some figures that are more related to Powerline. MOCA is a little bit higher for some situations. It's 5 milliseconds or something like that. But that's something that it's not only relatively small compared to what you can find in Wi-Fi, or at least in some Wi-Fi technologies, but it is also very stable. Okay, so that's something that if you have 2 milliseconds, it will always be 2 milliseconds. That's especially important for gamers, for instance. And actually, just as a side note, I mean, we see many gamers that are using Powerline devices, even if they have a Wi-Fi extender capability, they just use the Powerline part to connect to their gateway just because of the latency, because Wi-Fi is not good for them. As I mentioned, it's easy to install, and potentially it provides higher throughput between backhaul access points. That is not always the case, and I'm the first one to say that. You will see that at the end of the presentation, why the backhauling, especially with Powerlines, are not mere-close solutions. Okay? So a home connectivity system does not need or should not always choose the wide backhaul, especially if it is Powerline. It has to choose the right backhaul in each situation. And actually, that's what we want to correct with the proposal that we are doing here, that the connectivity system should choose the wide backhaul only when it is better, which is something that, as we will see later on, is not exactly the case today. Another advantage, especially today, where we see this packed spectrum, is that by putting the backhauling in a wired medium, we are offloading the spectrum, and we are really using the spectrum where it can provide the better capacity in the front haul. So the idea is that to use the spectrum only where it is needed. Reduction of access point power consumption, okay, that's also a side effect, and it's also linked with the reducing of the physical size. Actually, at the end, and that's a funny thing for us engineers, at the end, it is also true that the users take decisions on which devices to buy or which devices to place in their home based on how small or how beautiful they are. Okay, so form factor is an important parameter for deciding on something, on putting a device in your home. And finally, I mean, that's always something I always say again. I mean, at the end, does it make sense to put a Wi-Fi sometimes where you have a blind spot in your home where Wi-Fi does not arrive? Does it make sense to put a Wi-Fi repeater to get there? Because it's not always, well, you already have Wi-Fi difficulties. It is true that, again, us as engineers will be very good to select the right places to put the Wi-Fi extenders. Which is basically, okay, you put it halfway. But from the experience, from a user perspective, normally what the end user do normally is when they have to place a Wi-Fi extender, okay, in a room I don't have enough throughput through Wi-Fi, what I put is a Wi-Fi extender just in that room. Okay, so at the end doesn't make any sense. Okay, but it happens. Okay, so that's a little bit of the rationale why we think that including wired media, or at least optimizing the use of wired media in EasyMesh makes sense. Okay, as I say, it's not a matter that we think that it has to be used all the time, but it has to be used in the optimal way whenever it helps. So at the end, what we expect to have is something like this, where you will have a gateway, and this gateway here I'm showing the front holes as in red always. As I say, that's not always the case, but okay, for EasyMesh, that's another question for EasyMesh. Let's imagine that for the moment. And then you will have the back holes that can be either wired or either wired or wireless. Okay, I mean, and this situation can dynamically change, and EasyMesh should be able to cope with that. Okay. So just for those who do not, that are not really familiar to the technologies, just one slide on each of the technology that we are handling in MaxLinear. One is the G.hn, which is an IoT standard, which is multi-medium. So I just depicted here the four main mediums: coaxial, twisted pairs, power lines, and recently Li-Fi as well. Okay, which is another technology that is really starting right now. The idea is to use light instead of normal radio signals. It's quite successful in terms of technology. So, as I said before, I mean, the objective for the technology was developed in order to be easy to install, to have low latency and predictable latency. And this is that is done by using TDMA and contention-based. Okay, a good mix of these two medium access approaches. While Wi-Fi is normally used contention-based, which is not the perfect solution for deployments where you have congestion. Okay, in that case, TDMA is a little bit better to get the latency control. Okay. The other type of wired backhaul that we are presenting is MOCA. Okay, which is, well, this long slide I will not enter into all the details. Okay, just a second, I will close the door because I mean it's not easy to work from home when you are in quarantine. Okay. Yeah, sorry for that. Okay, so MOCA is it's mainly based on coaxial. Okay, and as I say, it provides a nice backhaul solution up to 2.5 gigabit per second. So the case of G.hn and or power line and MOCA is slightly different because, as we will see later on, I mean, whenever you have MOCA, it's in the vast majority of the cases it's better to switch to MOCA. Okay, instead of Wi-Fi because the throughputs that you can get are really high. Okay, so any questions so far? No. So just I tried to summarize a little bit what are the use cases that where a wired backhaul can help. Okay. So the most normal use case is what we call internally double backhaul. Okay, so you may have devices that have the capability of having, of course, a front haul wireless, a backhaul wireless, but also wired backhaul. And this is quite common. For instance, in Asia, there are several solutions like this already deployed, okay, not mainly by Huawei. So at the end, these are expensive systems. Okay, so you can have several technologies included in the agent. Of course, I mean, the lower the cost is, the better. Okay, but at the end, the vast majority of the cost is not even coming from the interfaces. Okay? So this is quite a usual use case, I would say. So basically, what you do in this situation is that someone, and in this case, the EASYMESH controller, has to decide what is the best backhaul for that specific link, if it is wireless or if it is wired. I mean, it is very likely that if the distance is relatively low and you don't have walls in the middle, maybe the Wi-Fi backhaul may be the best option. If you have a longer distance and 3 walls in the middle, then it's very likely that a power line backhaul would be better in the situation. So, but the idea is to have the choice between the two, and the controller takes a decision using the metrics of each of the 2 backhauls. It's also important that so far we are only considering to use one backhaul at a time. So there is no bonding, and there is no segregation of services between backhauls, which is something that for an advanced EasyMesh system could be something that could be envisioned, okay, to prioritize or to put, for instance, low latency services over the wired backhaul and best effort services over wireless backhaul to offload the wired backhaul. But again, that's we are far away from that, I think. The second use case is the fact that today many people have deployed wireless extenders with a wired backhaul, either MOCA or HN or even Ethernet. Okay. So these wired extenders can be upgraded to be EasyMesh agents and to participate in an EasyMesh system. Okay, that means that wherever you have a house that you already have some wireless extenders, then you can, by upgrading the software, you can make it an EasyMesh device, and then you can buy another EasyMesh device and put it on top of that to cover the blind spots. Okay. This is particularly interesting for service providers that are migrating from one approach to the other. And then the third use case that we see for wired extenders is, or for wired backhauling is, let's imagine that you have a Wi-Fi mesh system and there is a particularly difficult link for Wi-Fi because that link, well, for some reason you have 2 or 3 walls and you don't have the possibility to put something in the middle, okay, any relay in the middle. So in that case, you can not replace, but by adding an additional device with a wired backhaul, you can bypass this problematic link. Okay. So these are basically, as I say, these are basically the 3 use cases. There are many more. I mean, there are many more reasons to use wired backhaul, but this is, as we see, the rationale, the 3 main drivers for service provider to use a combination of wired and wireless backhaul for their connectivity system. Okay, So what?
Marcos?
Yes.
I have a question.
Yes.
In the figures you draw, you always put the G.hn interface as part of the node itself.
Mm-hmm.
But I had understood that actually usually it would be a separate device, so you would have.
It's a good question, and actually I'm coming to that right now. Okay, so you will see it. Okay, so on the backhaul selection. Okay, so let me just talk a little bit on the backhaul selection. I will come back to your question. Okay, in the next slides, because that's part of the some of the decisions that we need to take. So first, an analysis on how the situation is now with the wired backhauling. So today, I mean, and I did not analyze the whole solutions. Okay, all the solutions that are in the market. I would say there are many proprietary solutions, but the typical answer that I get when I ask how do you deal with the wired backhaul is that if a Wi-Fi mesh controller on it, even in the case it's even the agent, when an agent has to decide on the backhauling, basically the algorithm is if I have a wired backhaul, I use it. If not, I use a wireless. Okay, because you assume that the wired backhaul is always better than the wireless because you have a Ethernet connection. As I said at the beginning of my presentation, that is not mandatorily the case. Okay, and our goal should be to acknowledge the fact that sometimes the wired backhaul is not the best option. Okay, so this decision between wired and wireless should not be as automatic as deciding if I have a wired, I use it. Okay. So basically, the idea is that what we need to consider is that the wired backhaul needs also to get the metrics, and the controller has to use these metrics to make a decision on which is the right backhaul to do. I mean, if we don't do that, know that the system will continue to work, okay? But sometimes it will not select the optimal backhauling. Sometimes it will say, yeah, I have an Ethernet backhaul, so I use it, but in reality it's a power line backhaul, and in that case, with metrics that are not as good as the wireless, okay? So you are choosing a path that is not optimal. So in our experience, in the majority of the case, it would be good because normally the wired is normally better than wireless. But there would be a percentage of cases where that will not be the cases, and that we need to identify. So this is basically what I say. Okay, so our proposal would be to work to change the algorithm. So instead of saying if the wired backhauling is plugging in, then we go to the backhauling, to move to a relatively more complex algorithm where we say if the wired backhauling is plugged in, then you examine the metrics of the wired backhauling, and you examine the metrics of the possible wireless, and you make an educated decision on what is the best between the wireless and the wired backhauling. Okay. Now, coming back to your question, this is what I say so far is very nice and in practice, in theory. Okay, that is how things should work in a normal installation, and the figures I showed before are very nice, but that is not what happens in reality. Okay, what happens in reality is something like this. Actually, in a normal wired deployment, you will have a satellite or an agent, okay, that is relatively integrated when you have basically you have a host and you have a Wi-Fi interface and a G.hn or MOCA or whatever interface, and everything is integrated on the same box. Okay, so the agent has knowledge of the two interfaces and can get the metrics of the two interfaces. In the gateway, however, and I would say unfortunately, this is not really the situation. The situation is that the gateways normally have an Ethernet interface, and normally you plug a power line extender to that interface. So that means that from a gateway perspective, what it sees is an Ethernet interface with, I don't know, 100 or 1 gigabit capacity. Okay. But in reality, this interface is connected to a G.hn interface that has a link to capacity, okay, which will be normally lower than the 1 gigabit of the Ethernet interface. Okay, just to give you an estimation of what a normal link is today, and right now connected through power line, I'm getting, I think, 300 megabits per second Ethernet layer, okay, which is well below 1 gigabit, but it's well far much better than the Wi-Fi link that they have right now, which is 2 megabits or something like that. Okay, so the challenge is, how do we integrate this practical situation in the EASYMESH ecosystem? Okay, and there are several ways to do that. So the first option is to make the controller think that this link is a virtual link. Okay, so instead of saying this is a composite channel composed of 2 links, link 1 and link 2, then we may consider that this is a virtual link with a link metric, which is the minimum between link 1 and link 2. Okay, so the satellite is still discovered through EASYMESH, but the trick is done in the driver, where we say, yeah, that says, yeah, it is true that this is an Ethernet interface, but I discovered through other means, I mean, that can be another layer 2 protocol, that in reality there is something behind my Ethernet interface, which is G.hn, for instance. So the metrics that I will report for this link will not be the metrics of Ethernet, but and the type, but it will be type and metrics of HN, because it is assumed that the bottleneck would be the HN side and not the Ethernet interface, which is normally half a meter Ethernet cable. Okay. So the controller will interpret the Ethernet link as a G.hn link, and make the educated decisions basing on the metrics that it has acquired. Okay, so you compare this virtual link with the metrics that you get from the wireless links, and you decide which of them is better. Okay, so that's the first option. Okay, that is doable. Okay, that's something that we are considering, and but no decision is taken yet. The second option is to consider the 2 links separately. To say, yeah, okay, I let you know that EASYMESH is based on 1905, where we say, okay, we have a 1905 agent, not an EASYMESH agent, or maybe yes. I mean, that's something we need to understand a little bit better. But the idea is that the G.hn extender, or MOCA, I mean, it's exactly the same, is discovered through the standard 1905 protocol. Okay, so in that case, the controller will receive the 2 links and will make the educated decisions. Okay, the controller will understand really that the composite channel is the minimum between link 1 and link 2 without the driver making any translation. The drawback of this solution, in a sense, is that the extender has to run a 1905 stack, which is always possible. Okay. And that the topology that is built in the controller needs to take into account not only the topology information, so links and metrics provided by the agents, but also the link and metrics that are provided by 1905 devices. Okay. Which, by the way, that's something that is healthy to do, okay, because, and that's something that we are working in BBF to understand the topology of the overall network and not only of the agents, because the user may plug in things that are not part of the EASYMESH system, okay, but that may be part of the topology of the topology of the home networking. So these are the two options that we are analyzing today. And I mean, the idea of this analysis, well, just before entering into that, by analyzing these two things that are common to these two possible options is that we already identified some needs that are needed for both options. Okay, first one is to open source the HN driver. Okay, so you need to be able from the gateway to identify that you have a G.hn interface. That's something that we will do. The acquisition, HN and MOCA for sure. Acquisition of 1905 metrics from HN and MOCA. That's something that will be part of the driver, actually. That's something that we are working on it. As I mentioned, we will need to modify the controller algorithms to take into account the wired backhaul metrics, which is something that is not specifically done right now. Okay. And last but not least, today there is a gap in EASYMESH, which is that you can signal an agent to change a backhaul link, wireless link, but there is no means to signal an agent that it has to switch to a given from wireless to wired or from wired to wireless. Okay. So this needs to be completed. So that means that we may need, and again, this is still under investigation, to define new TLVs or new message while keeping the TLVs. That's something we need to identify. But for sure, something needs to be on top of existing EASYMESH solution to optimize the use of wired backhaul. So how to do that? What is our preferred way, and what is the way that is being implemented so far? Well, it leads us to, there's some echo in the line. Now it's okay. So that leads me to talk a little bit about the EASYMESH ecosystem. So you all know that the EASYMESH is standard is developed by Wi-Fi Alliance, okay? That develops R1, R2, and R3, and R4 in the future. Yeah. But as I said at the beginning of my presentation, they are really more focused on the radio aspects and not so much on the wired aspects and in the overall architecture aspects. Okay, for them, and it is normal. I mean, that's what you could expect from them. They are really building an EASYMESH Wi-Fi system. Okay, while what the service provider need is a EASYMESH home networking system. Okay, including wired, wireless, and whatever other device that are not specifically connected through Wi-Fi. Then there is prplMesh with the open source stack, which is a great initiative, of course, and where we participate, where develops an open source implementation for the agents and gateways of the stack, which, as I said at the beginning, I think it's really a major achievement if we want this technology to be successful in the market. And then there is another project, which is BBF or BMAP. The idea of this other project that is in close relationship with prpl is to develop the carrier grade version of EASYMESH, understanding by carrier grade what I mentioned, moving the focus on just Wi-Fi to home networking, whatever that means, okay, with wired backhauls, topology, getting a broader view of what the home networking is and what EASYMESH can do. So the idea is to really build something on top of EASYMESH. It's not replacing EASYMESH, it's not correcting EASYMESH, it is just build on top of EASYMESH whatever is needed to make it good for a service provider deployment. And for that, as I say in my previous slide, we may need to develop, of course, data models. That's something that we are working, or we should be working right now. Okay, we are more focused on the topology aspects right now, but data models will be another of the drivers, and develop specific TLVs and message if needed, and that we hope could be integrated on top of prplMesh. Okay, by the prpl or BBF. That's something I understand is still under discussion. Okay. And that's it for my presentation. I'm not sure if I've been too short or long, but I'm open to any questions if you have.
I have a couple. So it starts with, so you mentioned indeed that steering of a backhaul link between wireless and wired is not currently supported, and we need to add TLVs for that. Is that something that you know of might have already been put on the list in the Wi-Fi Alliance for an evolution of multi-AP? Or is it something we should trigger now still while we're going through the R4 scope?
I mean, there are two answers for this. I mean, the first one is that, as I say, Wi-Fi Alliance is really bothered only by Wi-Fi links. Okay, so the answer to that question, Wi-Fi Alliance, which has been asked, by the way, has always been, yeah, well, that's not our problem. Okay, so we provide the wired, okay, possibility, but if someone wants to do it, it has to be done outside Wi-Fi Alliance. I think right now there is a note that was pushed by me in the standard saying, by the way, this can be wired power line link, for instance, and you need to acquire the message or something like that. But it's not in the priorities of Wi-Fi Alliance today. And you know how things work in Wi-Fi Alliance. Okay, it works by priorities. Okay. So the whole idea is that through BBF and the OBMAP project, we may want to develop some things and then push that to Wi-Fi Alliance, because at the end, the Wi-Fi Alliance is the owner of the standard.
So that's where we'll get when we've caught up entirely with the multi-AP spec of the Wi-Fi Alliance, and where we actually have additional features ready. Nothing stopping us from, in the meantime, also keep making sure that these things are brought to the attention.
No, sure.
So our 4 feature selection is in progress. I've pushed a contribution in there already. I would strongly suggest that we do that, because the problem is that if we develop TLVs, there'll be vendor-specific TLVs, and then when we go through approval of the Wi-Fi Alliance, maybe in a year, 2 years, they'll say, okay, we'll approve this, but TLV might be a different one. And then we have a migration situation.
Yeah, I mean,
we get them to immediately approve. If you have a concrete proposal that you could write up in a contribution, and we can push that in.
Yeah, I mean, there are. I don't think as everything in life, it's not black and white. I mean, I fully agree with you. The plan A should always be to go to Wi-Fi Alliance and to say, okay, this is what I want to do. This is something I identify is missing. Let's put it in Wi-Fi Alliance. Here I'm giving an example, okay, because this is what we think from MaxLinear that is missing, but there are many other things that are missing. For instance, more KPIs, well, how to deal with latency, these kind of things. Wi-Fi Alliance is not always as fast as they should in order to include.
Yeah, so we understand that. The question is just.
Yeah, but
is it something that you could quickly put together so that we can try to push it in? It might be that at some point in time there even was a contribution to suggest this, because I recall having this discussion before. I get that they have.
No, it was dealt with in R2, okay, but you all know the problems that R2 had on resources. So at the end, it was really focused on several features.
Did they end up in R3 then? Because most of the R2 things that weren't completed were pushed into R3.
Yeah, and many things were put into R3, and some of the things were say, okay, if it is not pure Wi-Fi, we don't implement that, because.
Really? Okay.
Yeah.
So maybe that's the one we should pick up again and try to push into R4.
Yeah, and again, we don't have a complete solution yet, okay, to say, okay, this is what we need to standardize. Okay?
Well, if there was a contribution or technical discussion in already in R2, then it's just a matter of throwing that back into the voting list of things.
I don't think it was so in depth, okay? I think the contribution was we need to deal with wired backhauls, But at that time, it was at the beginning of Wi-Fi mesh, so there was not really, all the problems were not really identified. Okay, so there was not a contribution saying we need an additional message. Okay, it was we need to deal with wire backhaul, and the answer was yeah, we do the minimum, which is we have logical Ethernet, and that's the maximum that Wi-Fi Alliance will do. Okay. Now, if we come with another contribution saying we need this message because for this situation it is needed for wire backhaul, things may be different. I agree. Okay. So my preferred approach, and that's what I've been defending in BBF, is to let's identify the problems, let's work on the problems, let's provide Wi-Fi Alliance with inputs on what the problems are and need to be identified. If Wi-Fi Alliance does it, perfect. If it's not done by Wi-Fi Alliance in this release, we cannot wait for it, then we will do it in BBF. Okay, so, but not to, plan A is always Wi-Fi Alliance, plan B is BBF, pushing into Wi-Fi Alliance, because as I say, I do think that EASYMESH is owned by Wi-Fi Alliance. It should not, okay, but it is a reality. And we need to, it is better to have everything in a common standard.
Okay. So I've got your contribution here for enhanced backhaul discovery in, is it in there somewhere?
That was in R2 that was provided by Huawei and MaxLinear at the time. And enhanced backhaul discovery. And if you see at that time, it was really on discovery, not so much on backhaul selection. At the end, that was translated into a note in the standard saying that other technologies that pure Ethernet can be discovered through 1905.1a. That's it. Okay, so that's the maximum that was done in Wi-Fi Alliance. But it's true, okay, which is basically true. So I don't think the discovery is the problem anymore. It's just the backhaul selection.
Well, backhaul selection requires at the very least the ability to, well, gathering the metrics, I think, is in there, right?
Yeah, gathering the metrics is not a problem. Discovery and gathering is okay.
Yeah, so you've got 1905.1a. If we have those extensions in, then you should be able to discover G.hn, Powerline or whatever devices that that do report their link metrics and do give us topology information.
Yeah.
So the so being able to know what the link quality is, I suspect is already in there. Then maybe
yes.
we have that. Okay. So it's just a matter of then having the steering ability on a backhaul link to select between a wired and wireless.
Yes.
Yeah. Okay.
I have a couple of remarks about that. First remark is that we could actually abuse the existing steering message. The steering message has a target BSS ID. If in the target BSS ID you just use the MAC address of the G.hn extender, you basically have a way of steering to G.hn.
That could be an easy solution. That's why I'm not very categorical on what the solution should be. I mean, the one you present is one solution: reuse existing message and TLV and interpret them in a different way, which is nice. Okay, I mean, I think it could be a nice way to do that. Other ways would be to create a new message. That's something we need to analyze. What is the best solution from a development perspective?
I like Arnold's idea. You can do it towards Ethernet as well, because in 1905, every Ethernet interface on every device has a unique MAC address.
Yeah, I also like it. I think it makes sense. Yeah.
Okay.
However, during this presentation, I took a step back and I was thinking, do you really need to steer it from the controller? Because actually, before even connecting to the controller, the agent will already have to make a decision on which backhaul to select. So there has to be some backhaul selection algorithm in the agent, which can be the one that we have now. If wired is available, use wired, and otherwise use wireless. But since we anyway need to have a backhaul selection algorithm in the agent, you could say put the logic there.
Yeah, but so So here's and that's was going to be my next point. There are two layers there. First is that the agent doesn't know the entire network topology. The second would be that the EASYMESH itself doesn't know the entire network topology and is missing context. One of those contexts can be that an important decision element is what is your total bandwidth aggregated from the extender, from the agent, to the internet, because that's almost always the important case. Huh? What is your bandwidth to the internet from every individual agent and the stations, looking at the stations behind them? It might also be system load. You might also say that, well, one of these links is heavily loaded, so we need to move to some extenders to a link that doesn't have quite the same link quality, but just to be able to distribute it there. And those are decisions that are taken outside of prpl_mesh. In the full topology, there are other protocols that do topology discovery, and while this is 1905 based, so we could integrate into prpl_mesh, others are not. So it's always been the intention to have the intelligence sitting outside of prpl_mesh.
At the end, I fully agree with you, Wouter. At the end, the controller will take educated decisions, taking into account the information coming from the 1905 layer of EasyMesh, but also from other factors that are outside EasyMesh, and take some decisions.
So the controller will push the steering, but the controller doesn't necessarily have all the knowledge and all the algorithms inside of it to be able to make the right decision.
Well, it depends on what you call the controller, and that's a discussion we had in the BMAP.
The controller from a 1905 perspective, as in the protocol termination from the multi-AP position, as in the one that terminates the protocol, is just the one that sends the message. The intelligence, we have some intelligence inside prpl_mesh. However, the intent is to make it possible for somebody through the high-level API to do an external controller intelligence to do optimal selection of and channel selection and that sort of thing.
Yeah, at the end we have two controllers. We have the EasyMesh controller that controls EasyMesh and gets the EasyMesh metrics, and then you have a network controller that discusses with an EasyMesh controller through an external API that has a broader view of the network and can take the decisions on the overall network. And these decisions will affect the the EasyMesh controller.
We have 3 or potentially 4 even. So you have the protocol termination in multi-AP terminology controller. Yeah. You have the algorithm, the network selection that is inside prpl_mesh. You have through the high-level API the ability to have an external component that pushes these decisions. And that in itself might actually be just a relay for to a cloud-based controller or network controller that pushes through it to say that, well, here are the right decisions.
Or that pushes policies or things like that. Indeed.
Or so it's policies, yes. So it's all flu. So all not that clear where all the decisions need to be taken.
Yeah.
So the design that we're working on at the moment in OBMAP with the broadband form is that we're defining a network topology component and a standardized API through that would sit next to prpl_mesh. And an external network controller outside of prpl_mesh would be able to use all the topology information in there, which will include everything that prpl_mesh picks up, as well as the additional information that it gets from other algorithms, agents feeding into that.
Yeah, indeed, exactly.
So bear this in mind when you say that the controller algorithm, the selection algorithm should be this or that. The one in prpl_mesh is always going to be a basic implementation. It's not. It may be used in deployment for sure. I don't know what the link will be. But the goal of one of the goals of prpl_mesh has always been that it must be possible for a third party to put in that intelligence externally.
Totally good. Totally agree. Yeah. And coming back to the first question, what happens when you start up the network? I agree with you about it as well. I mean, at the end, you do need to have some intelligence in the agent to decide locally, but only with the information that the agent has, which may not be the best view. So the agent will take a local decision saying, okay, it seems that this is the best one. So I pick this for startup. I set up the network with this, but I give the metrics of all my interfaces. Then the controller has a second step, which is the EasyMesh controller, to say, okay, instead of this one, use this other one, because from the context that I see, that seems to be the best way. Then it is true that you have additional layers on top that can take other decisions, okay, on the best thing to do. So it's an hierarchical approach. So, but from a EasyMesh perspective, it is true that we need a local intelligence in the agent, using only the local information, then intelligence in the controller using the EasyMesh data and the APIs and all the levels that we will discuss in OBMAP and all that, indeed.
Yeah, so then the agent selection itself of the appropriate interface, is that something that we want to address in prplMesh? I remember last year in the face-to-face that we had a discussion over that as well, where I explained all the different aspects in there, which is to recap. For example, you deploy an extender. It's never been provisioned before. It doesn't have any status whatsoever. You plug it into an Ethernet interface. You get link on that Ethernet interface, but that doesn't necessarily mean that it's an uplink towards the controller or to the internet. It could just be that you plug the set-top box or a PC into that, right? So then you have the, then what can happen is that you can start doing a DHCP request, something outside of prplMesh, over that Ethernet interface. And based on that, based on getting a response, that could give you a hint of, well, this is actually connected to my upstream router, which is likely to be the controller. So at least now I have something. Once you have that link up, that's when you can start doing discovery on in multi-AP and try to see if you detect the controller. If you don't, you might actually be connected to, not be connected to the controller, at which point in time you'll need to go through an onboarding procedure, which will likely onboard you on do an AP auto configuration over a wireless. At which point in time you might have dual links. You might be connected via Ethernet to a link to the controller and over a wireless backhaul connection as well. And that's when the selection really starts to come in and starts to become important, and where you possibly need to reconfigure your layer 2 bridge in your extender to make sure that you don't throw them all into the same bridge, and you don't create a network loop, and etc. So some of these things have been discussed in multi-AP of how to deal with multiple loops, etc. But it's all it's not defined yet. I think that was still now pushed out to R3.
No, and this has been discussed even in R2. Okay, that
so the question is, to what extent do we care about the selection, the backhaul selection inside the agent? To what extent is prplMesh exposed to this, and to what extent is it the rest of the software stack on the extender that has to manage these things and make sure that the appropriate links are available?
That's a good question. I don't have the answer right now. I mean, it depends. I'm not an expert on the software in the agent today. Okay, my guess is that that there will be quite a lot of involvement of the upper layers. Okay, and that is independent of prplMesh. That prplMesh needs to give the ways to identify. Okay, I have so many interfaces. Now decide which one to use at the startup. Okay. And that's something that the upper layers need to solve. But at least some information has to be provided to the upper layers by the agent.
Yeah. So I've experienced doing a proprietary implementation of extenders where there is a whole selection algorithm that's a whole state machine really that takes that into all of those aspects into account. Is plugged into the DHCP client, plugged into discovery. etc., and then has the ability to really reconfigure the local bridge, and then tell the wireless extender logic of this is your upstream interface. This is what you should be using. So it's providing that information, and then after that it becomes the slave really of the controller that decides that for it.
Well, it would be
there's
nice.
always a fallback, of course, because at some point in time you might lose connectivity. Some Ethernet switch might be disconnected upstream. Some upstream agent that you're connected over through wireless backhaul is suddenly loses its upstream, etc. So that always needs to be ready to kick in again to make sure that it finds some way to route back to its controller.
Let me just jump in here, because it's past 12 o'clock now, at least in my location. So that means it's time for our break. So yeah, if you want to continue this discussion, please go ahead. But for everyone else, I'll see you in about an hour for the next presentation. So yeah. Next presentation will be by Thomas, the hands-on session. So yeah, see you there, and enjoy your lunch or dinner or breakfast, whatever.
Okay, thank you.
Goodbye.
Thank you, Marcos.
Or in Dave's case, midnight.
Thank you very much.
Bye.